Right? Here's your rise. That's your rise. That's your run. Okay, so rise over run is your slope. Okay? You guys with me on that? What is this line called? Does anybody know the name of this line in geometry? No. Well, not in that context, but say about in the context of this. The context of a circle.
A chord.
Nice. That's not what I had in mind.
Okay.
How about that?
A chord with an extra part.
Thank you. Yes, that's called a secant. That's called a secant. Okay? All right, you guys with me on that? All right. Look what happens to the secant so notice that this distance here is h, okay? That distance there is h, the horizontal distance. Everybody know what I'm talking about. What's h? This distance here, from there to there. Okay, you guys with me on that? Beta, I'm losing you guys. Okay, look what happens, okay? Look what happens. What's happening to h? What's happening to the secant line?
It's going closer to the parabola.
What do you mean by closer to zero? I mean,
it's blending into the parabola.
No. Think again. Geometrical terms. The secant. Okay, so think about it this way here.
The slope of the secant. You're decreasing the secant.
Okay, think about it this way. Hang on. Just don't throw things out. Okay, just think about it. Okay, here's your secant. Okay, here's another secant. And then all of a sudden it becomes a tangent. So what's a tangent? A line that touches a circle at one place only. Same thing that happens to this dude here. As A gets closer and closer and closer and closer to B, that line is eventually going to become like a tangent. Okay? So again, as A is getting closer and closer to B, what's happening to H? What's happening to H? Can you be a little mathematical? Does this help? Thank you. Exactly, I'm telling you to be mathematical. And look, isn't this what this is all about? Isn't that what it's all about? So what this equation is really telling you is that this then becomes the slope of the tangent line. Because then we just agree that this was the slope of the secant line. And then we say that if this goes towards 0, the secant becomes a tangent. Then does it then become the slope of the tangent? I'm done. You guys get it? Yeah, you're going to need it.
Okay. What would the question be?
Good question. I have no idea. Let's take a look.
Okay. He's like, I get it, but I don't understand. What is it?
What are you supposed to do? Well, let's take a look. Let's take a look at 11.2. Yeah. 11.2. Okay, let's take a look at number 69 on page 799. Number 69, page 799. Is everybody there? Fx equals 3x minus 1. Okay? Evelina, wake up, man. Beta, no book. Bad girl. Yeah, but that doesn't mean that Beta's got a book. It means Awesome's got a book. Okay, so this is what they're asking you to do. Limit h goes to 0 of fx plus h minus fx all over h. Remember that fx plus h means plug it in. So you're going to go limit h goes to 0. You're going to take x plus h and shove it in here. So then that becomes 3x plus h minus 1. Does everybody see that? Okay, I'm going to let me pause here for a minute. And then I need to do the minus fx. So it's going to be minus 3x minus 1. And all of this is over h. Okay, you guys get me on that? All right. So then this is equal to limit. So notice that I do not throw away the limit stuff. That needs to be there. So if I expand this out on the top, I get 3x plus 3h minus 1 minus 3x plus 1 all over h. Everybody okay on that? Okay, plug and chug and distribute and stuff like that. Now what do? You cancel this. You cancel the minus 1 and you cancel the h's. Okay, and then you just get 3, right? Because one of the properties that we learned yesterday is that limit of x goes to a of a constant is c. That's one of the properties you are supposed to have copied. One of the properties you are supposed to have copied from the text yesterday. Okay, so then this limit becomes 3. Now again, what is this limit indicate physically? The slope of the tangent line. What's the slope of this line?
3.
Wow, is that a surprise or what? The line itself is a tangent to itself. Hannah, that is intense. That is intense. No. Okay, so tangents in circles are geometry. In calculus, it's always... can I kind of scroll up here? Say if I draw a funky funk. Say I draw a funky funk. Okay? A tangent is this line here. And the stuff that we did, this limit crap, still, hang on. And the stuff that I just did here, is telling you it's the slope of this line. And it could be anywhere. It could be here. Oops. You guys get the idea there? Ugly. And how about here? What's the slope of this line? 0. Okay, nice. 0.
Wait, so what's a tangent of a straight line?
Yeah, how could it be a tangent?
Deep question. What do you think?
The line.
It's like on top of it.
No. I mean, so you know that this is 0, right? Is the slope increasing? Yes? What do you think it's going to? Undefined, but conceptually? Sorry? No. Perpendicular is the nature of the line. What's the slope of the line? Sorry? Yeah. Right, you're increasing. Okay, what's the biggest number you know?
Infinity.
Okay, so, all right. Okay, you guys with me on that? Okay, do we have some more stuff here? Okay, so can you work this out, please? Okay, so work this problem out. Right off the bat, you know what the answer ought to be.
6.
-6. Nice, awesome. Good job. So make sure you do get a -6 by doing the plug and chug, okay? Yes, it looks like there's no time for